Chemists use the word reaction to describe a change. When you see the word reaction, you know that some sort of change is being discussed. In the broadest sense, reactions can be classified into two categories, either physical or chemical. Physical reactions or changes abound in our everyday life. A physical reaction is a change where no new chemicals are formed. Pause the video for about 15 seconds and see how many physical changes or reactions you can come up with. There are dozens of examples of physical changes in our everyday life, such as combing our hair or changing clothes. These are changes where no new chemicals are formed. Other examples include grinding something into smaller pieces, tearing or breaking something such as glass. No new chemicals are formed. In chemistry, phase or state changes like melting and freezing, boiling and condensing, as well as dissolving, are all important physical reactions. As a side note, not all chemicals will melt or boil. Sometimes chemicals decompose, which is a chemical reaction, before they melt or boil. It is useful to look at chemical equations to describe phase changes, which again are important physical reactions in chemistry. Chemical equations use chemical formulas, phases, and an arrow to describe a reaction. If we look at the chemical equation, which represents the melting of ice, we see capital H2 capital O, which is the chemical formula for water, and in parentheses the letter S, which stands for solid. Chemists use the common word ice for solid water. The arrow signifies the change, and on the right-hand side of the equation we have capital H2 capital O with an L in parentheses to indicate that the chemical is in the liquid phase. Chemists refer to liquid water as water, like we do in our everyday life. Note that the same chemical formula, H2O, is on both sides of the arrow. Although a phase change from solid to liquid has occurred, no new chemical is formed. The next chemical equation represents the dissolving of table salt, or capital N lowercase a, capital C lowercase l, or sodium chloride. At room temperature, sodium chloride is a solid, but when it is added to water, it dissolves. Notice that the chemical formula is the same on both sides of the arrow, NaCl, but the phase on each side is different. S for solid on the left-hand side, and AQ, which stands for aqueous or dissolved in water, on the right. Dissolving is a physical reaction since no new chemical is formed. There are some video clips in Canvas of sugar dissolving in water as well as ice melting. The video of sugar dissolving is particularly useful because it gives a molecular view of the process of dissolving. I encourage you to take a look at these brief videos.